Hello, this video is for review 5.1 to 5.3 for your quiz, and let's go ahead and get going. I'm going to remind you of a couple things here before we actually start. The first thing that I'm going to remind you about is going back and forth between radicals and rational exponents. Remember, rational exponents means fraction exponents. So for instance, if you have a to the m over n, you should change that, or you can change that into a root with an n right there and an m on there. Another form of that, by the way, is something like this. That's fine. And one more note that I want to provide for you is that if you have a square root, so like the square root of a number, is really a to the 1/2, because there's an invisible 2 right there called the index. Okay, so those are some little things that I wanted to bring up before we start. So let's take a look at number 1. It says rewrite each of the following rational exponents as radicals. Okay, so if I have a fourth root, let me set up my root. This 4 goes right there, the 5 goes inside, and the 23 is there, and I'm done. We don't really have to do anything else here, because it just asked me to rewrite it in a radical form. I'm going to clean that up, and let's go on to B. For 25x is in the parentheses, so let's set up the root, and let's make sure we throw 25x in the root. And again, we got a 3 here, so we'll put a 3 here. We have a 7 in the numerator, and the 7 in the numerator has to go to both 25 and x. Okay, so there's that one. I will do colors for the next one as well. So let's go ahead and set up our root. Okay, we have 3xy in parentheses. And let's go ahead and get this 5 right here, because that's where that goes. Denominator goes in the root, in the little tail of the root. And the -6, two ways we could do this. And the -6 is going to be going right here. -6. Now, this is one way to write this. Another way to write this, even though it doesn't entirely ask for it, it could be 1 over 5 root parentheses 3xy to the 6. The reason we're allowed to do that is because, please keep in mind, negative exponents imply reciprocals. So I'll just type a little note here. If you see a negative exponent, I'll then take the reciprocal. In other words, flip. Let's get that the right size, and let's go on to the next one. Color 2. Let's change it to green. I like green. That's this one. Oh, I don't know where I want to put this. Do it smaller. That's going to be better. Okay. So now let's go ahead and keep going with the next one. That's going to be 27. So this one depends on your teacher, but in my class, I asked you guys to look at the Powerful Numbers booklet. The Powerful Numbers booklet has 27, and it's 3 times 3 times 3. And what we want is 2 of those 3's multiplied out. So this is going to be my answer, 3 times 3, which is 9. Same thing for 32 in my Powerful Numbers booklet. So Powerful Numbers booklet, I find 32, and 32 was, I think, 2, if you look at your Powerful Numbers booklet, written out 5 times multiplied. And again, that blue 2 tells me I only want 2 of those 2's multiplied out. So my answer here is going to be 4. You could, again, put these in your calculator, but you could also use your Powerful Numbers booklet to help you with it. Okay, number 3 says rewrite each of the roots using rational exponents. So again, Please note when you don't see any number here in the tail, that number is always a 2. Always, always, always. So now the way we'll write this, let's put 17x in parentheses. We got this 9, which is the numerator, and then we have the black 2 here, which is the denominator. So 17x in parentheses to the 9/2 power. I could answer this two ways for b. The first way that I could answer it is 1 over y to the, and actually let me do some colors here since I said I would do that. I have 1 over y. Now I have this black 5, so that's the denominator, and I have this green 6, which is the numerator. So that's my answer. A different way I could write this is y to the negative 6 over 5. Because again, it works the other way around too. If you see a negative exponent, to take the reciprocal, and if you want to take the reciprocal, use a negative exponent. Either one of those would be fine if we don't tell you anything about positive or negative exponents. Let's go to C. So C again is going to be x, and then we'll do this 4. It's supposed to be green. This 4 is right there in the numerator, and it's going to be divided by that black 5 right there. And I believe this x was supposed to be blue, but that's your answer, x to the 4 over 5. Okay, now let's find the real solutions for 4, A, B, and C. And I hope you're not watching the whole thing if you don't need it. Maybe, I mean, you're welcome to watch. There's nothing exciting going on here except me talking, which is very exciting. But you're welcome to go ahead and skip around if you'd like. Let's go and solve number 4A. So for this one, I need to multiply by 3 on both sides. Because who likes fractions? I like fractions. You may not like fractions. And if you don't like fractions, let's get rid of the 1/3. So those 3's are canceled. We got a 3 and a 1/3 cancel. And now we have x to the 4th equals 432 times 3, which I believe is 1296. You can use a calculator, check that. Second, I want to get rid of the 4th power because I want to solve for x. So what I want then is I want x is equal to 1296 to the 1/4. I want the 4th root. Your teacher might have also shown you the 4th root of 1296. We'll get you the answer. I'm just going to put this here to show you what I did. So I took the 4th root of both sides and I get 1296 to the 4th, or the 4th root of 1296. I'm going to clean this up here just to make sure that we're clear. And then I need to solve that. And to solve that, I'm looking for a number that is multiplied out 4 times to get 1296. Now, you can plug that directly into your calculator if you want, or if you want to think about it a little bit and try to find that number, you will find that it's 6 4 times, and you only need one of those. So your answer is 6. For B, we have x minus 3 to the 5th, so let's go on and get rid of that x minus 3 to the 5th. Equals 150. Hold on just a second here. Yep. Oh, hey, these are all the answers. I could check myself here. All right, excellent. Okay, so let's just finish up here. X minus 3 to the 5th equals 150. So again, what I need to do to get rid of that exponent of a 5 is I need to take the 5th root. So I'll take the 5th root of both sides. And what I get here is I get x minus 3 equals 150 5th root, or 150 to the 1/5. And then, let's just add 3 over. And I get x equals 3 plus 150 to the 1/5. And that's going to be some decimal. Let's see what the answer is here if we look for it. That's going to be 5.72. So 5.72. Doink. Woohoo, we got it. Okay, oh boy, I can't circle anything. Okay, let's try that again. Yeah. All right, let's go in and get C. I'm going to squeeze that on down here. So for C, well, there's that 3 in front that I don't like, so let's divide by 3 on both sides. Okay, I'm sorry if my handwriting is not as good as your teacher's. It's not my fault. Let's see, I believe that's 49. Okay, so now let's take the square root to both sides, which is something we're more used to, hopefully. So take the square root of both sides. And when you take the square root of that, you get x plus 4 squared. I'm sorry, x plus 4, because the square root and the square cancel, equal plus and minus 7. All right, solving for x, subtract the 4. We get x equals 4, negative 4, because we subtracted. We get negative 4 plus 7. We also get one more answer. We get negative 4 minus 7. And both of those answers yield 3 and negative 11. Okay, number 5. Okay, so this is something that I posted on Schoology for my account, so I'm going to show you that quickly in case you needed it, and you can kind of freeze the video and copy it down if you like. What I posted for my kids was this frequently asked questions, like when can you divide numbers? When can you multiply the numbers and subtract the exponents? So this problem that we're doing right now is 75 divided by 15, and both of these have the 2/3 power. So let's go here. So when you do that, when you have something like that, you can actually divide the numbers. Like this problem was to the 1/2 and 1/2. Each number was to the 1/2. You just divide 20 divided by 5. Keep the exponent. So here, let's do 75 divided by 15. 75 divided by 15 is 5. Now we have 5 to the 2/3 raised to the 5th power. Now, what does this 5 do? That 5 is a power to a power. Or when you distribute the exponents, you can distribute the exponents when you have something in parentheses. So we can distribute this 5 here to the exponent. So we get 5 times 2 over 3. And 5 times 2 over 3 is going to be 10 over 3. So 5 to the 10 over 3. That's a 10 over 3. And I don't think that your teacher simplified it. Let me just double check that. Nope, that's it. Okay, let's go back. One more. A few more. Holy moly, we did a lot. So here, same idea. We have same exponents for the 3, 4, so we can multiply 3 times 4 here. That gets us 12. Keep the exponent. And let's put that 8/3 on the outside. And now let's distribute the exponent in. So now we're going to get 12. And when I say distribute, I just mean multiply both exponents together. So I get 3/4 times 8 over 3. I notice that the 3's cancel because I have 1 on top, 1 on bottom. And now I have 8 over 4, which is 12 to the 2nd. And that's equal to 144. And that's it. For number 6, to do the domain of the following functions, I could do that 2 ways. I'm going to look at a graph and see what's going on here. So let me open up my graphing calculator. Graph A and B and see what's going on. And then how much more do I have of this? Hopefully not that much. Oh my gosh, that's so much. And after that, is that it? Ah, and I have more. Okay, not too bad, not too bad. I'm just make sure that this is still recording.